This video, we're going to talk about 3.3 Objective 1, where we construct and interpret multiple bar graphs, stack plots, and multiple line charts. So let's start with some definitions first. Briefly describe how each of the following can be used to show multiple data sets: a multiple bar graph, a multiple line chart, and a stack plot. When is the stack plot most useful? So let's first start briefly describe how a multiple bar graph can be used to show multiple data sets. Choose the correct answer below. A multiple bar graph uses a set of bars for each data set. So that's A. Then briefly describe how a multiple line chart can be used to show multiple data sets, and choose the correct answer below. Multiple line chart uses a different line on the same chart for each data set, which is B. And then briefly describe how a stack plot can be used to show multiple data sets. Choose the correct answer below. A stack plot is similar to a multiple bar graph or multiple line chart, except that each subsequent bar or line is added to the prior ones rather than shown independently. So that's C. And then when is the stack plot most useful? A stack plot is best used with cumulative or relative frequency data, including time series data. It is most useful when the total of the data sets is important. So that's B. Let's go ahead and look at our next question. Determine whether the statement makes sense or is clearly true, or does not make sense or is clearly false, and explain clearly. On a stacked bar chart, such as that in the accompanying figure, the longest bar must also have the highest value in every individual data category. So that statement does not make sense. The longest bar could have a very large value in one category, but small values in other categories. So that's D. Remember, it's usually the cumulative. So just because it has the largest total sum doesn't necessarily mean that it has the biggest number in every category. The accompanying stack plot shows the numbers of higher education students enrolled in public and private colleges for a particular region for different years. The last few bars are projections, complete parts A and B. So in words, discuss the trends revealed in this graphic. The number of students in public colleges is consistently higher than the number of students in private colleges. The numbers of both types of students are roughly constant over time. So let's see. Then redraw the graph as a multiple line chart. Discuss the advantages and disadvantages of the two different representations of this particular data set. So we would be looking at 15 to 20 there is an interval of 5. And the purple goes from 0 to 15. So we would have A as our correct answer here, where the blue is 5 and the purple is 15. Stack plot makes it easier to examine the combined enrollment trend over time. The multiple line graph makes it easier to examine the public and private college trends over time, the individual trends, right? So that's B. So we can see that roughly we're staying roughly constant around 20,000 total over time for the two. We see that we're staying fairly constant at 15,000 for public and about 5,000 for private. Let's move on to question number 4. Consider the accompanying display of median salaries of males and females in recent years in complete parts A and B. So we see that the what gender trends does the graph convey? And I don't see the original graph other than these graphs that are down here. Guess there's, oh, here it is down here. There we go. There's the graph. So it looks like men have a higher median income on average than women, though it looks like men's median income has stayed fairly constant, whereas the median income of women looks to be going up, I'd say. But let's see what the answer is. The graph shows that males consistently have a much higher median salary than females. Males' salaries generally do not change, while female salaries generally increase over time. So yes, that's what I said I noticed the trends to be. So now let's represent this data here as a multiple line graph with 2 lines. So that would be, these are kind of hard to see because they're small, but the correct answer here is A. If we would take all of these plots and would show the trends here, and you'd be able to zoom in on these in my labs and get a better view, but the correct answer there is A. And then briefly discuss the advantages and disadvantages of the 2 different representations of this particular data set and choose the correct answer. So the line graph makes it easier to examine the trend over time. Also, the line graph is less cluttered, so the information is easier to understand and interpret. I would just say I would like those graphs to be a little bit bigger so we could see some more detail. That's not the fault of the type of graph there. It's just that they squeeze those 4 graphs onto one line, whereas we were just looking at a single graph here, and they can make it much larger so we could see the y-axis and the x-axis much better here. I'd like to have had these graphs about this size to compare, and I think we would have seen the advantages of having the line graphs a whole lot better that way. Let's go ahead and let's look at number 5. The following stack plot shows the number of bachelor's degrees awarded to males and females since 1970, so complete parts A through D. So remember, this number up here is representing the total, and you're going to have to find just this height right here in the pink if you want to find the number for females, and just the height in the blue right here if you want to find what's going on for males. Thankfully, this is multiple choice here. This is really hard when you try and eyeball this on these types of graphs for my labs. So let's go ahead and take a look here at what the first question is. Estimate the number of bachelor's degrees awarded to males and females separately in 2020. Number of bachelor's degrees awarded to males in 2020. So that's over here is what? And these are in thousands, right? Numbers in thousands. So this is above 500,000 is down here, and then 1,000 thousands would be a million. So we might be somewhere around 700, 800,000. somewhere around there. So which one of those matches? 840,000 looks about right there for number one. And then the height here for women looks like 2,000 minus, say, maybe 900 is 11,000, but then that's times 1,000, right? Because these are in thousands over here. So 0.0011, and this is maybe 1.1 million. So so that looks like right there, 1,160,000. Again, you can see that would have been really hard to just eyeball without a multiple choice option here, but we could estimate it and then see which answer looked the best. Now for the third option, about when were the number of bachelor's degrees equal for males and females? And that looks to be right here around somewhere between 1980 and, or right in here. So this right here in 1990, it looks like this height and this height are pretty close to being the same. So yeah, I'm going to guess 1990 is my answer here. And you would just have to compare the heights of the bars, that there's more men than women here before 1990, and then it looks like there's about the same there, and then women start to take over and get more bachelor's degrees than men after that. So now the next question is the number of degrees earned by females increases over the years. So, and then the number of degrees earned by males also increases over the years, just not as quickly, right? That this trend line here is steeper than this trend line here. So, and then do you think the stack plot is an effective way to display these data? Briefly discuss other graphics that might have been used instead. The stat plot makes it easy to see the changing total, but a double bar graph, one bar for males and one for females each year, would make the male-female comparison easier. So that'd be D. All right, that's it for this video, and we will come back next time, and we will talk about 3.3 Objective 2. See you for the next video.